Okay, so today we're moving on to geometric series. So with an arithmetic series, what we did was add a common difference. So we had D for the difference and we added it on to A to get the next term, and then we continued like that. In a geometric series, instead of adding a difference, we're multiplying by a common ratio. So we pick a constant, we multiply each term by that constant, and that's how you get a geometric series. Okay, so to find your common ratio, if they give you the series and they want you to find what that ratio is, then what you do is you take a term and you divide it by the term in front. So that could be T2 divided by T1, or T3 divided by T2, or Tn divided by Tn minus 1. Okay, so a couple of examples. Number one, we've got this series here, 2 plus 6 plus 18, etc. And we want to know, well, what is the common ratio to find this series? So to work out R, all you need to do is pick a term. So if we start with 6 and divide it by the term in front, you should get 3. Now that works whichever term you decide. So if you did 18, you divide it by 6, 54 divided by 18, you're going to get 3 each time. That's a geometric series. Okay, so in example 2, slightly different. They've given us a couple of numbers in the series and we have to find the one in between. So you have to think about the fact that the ratios are always the same. Okay, so what that means is that if we do x and we divide it by 1, we should get the same answer if we do 16 and we divide it by x. So now you're going to have this equation to solve, yeah? So x squared equals 16. So what's x? Well, we don't know whether or not we have a positive or a negative here. So you have to consider both cases. So x could be plus or minus, you take the square root, and it could be 4, because our series could go 1 plus 4 plus 16, and our common ratio would be 4, or our series could be 1 minus 4 plus 16, and our common ratio could be negative 4. We don't have enough information to know which, so you have to consider both. Okay, now your ratio, as we've just said, it could be negative. It could also be a fraction. Okay, it can be a decimal, it can be positive, negative, it can be a third, it can be anything at all. So having a look at this one, we've got 3/4 plus a half plus a third, and we need to find the common ratio. So we do the same thing we just did. To find your common ratio, you take one of the terms, so I'm going to pick a half, and you divide it by the term in front. So we divide it by 3/4. Okay, but to divide by a fraction, what we do is multiply by the reciprocal. So that's how we end up with our 4/3, which we hopefully can say, hey, that's equal to 2/3. Now you can double check if you did a third divided by a half. Well, like we just said, instead of dividing by a fraction, we multiply by the reciprocal, and we still end up with 2/3. So the common ratio for this series is 2/3. So that's how we find the common ratio. What I want to know is, well, how do I find the term of a series? Okay, so think about this. The first term, we still call it A. But now instead of doing A plus D to find the second term, we do A times the common ratio, so A times R. Well, for the third term, we do A times R again, so it's A times R squared. What about the nth term? How many R's are you going to be multiplying by? Well, for the first term, none. For the second term, R to the power of 1. For the third term, R to the power of 2. The nth term is going to be found by taking your first term and multiplying that by R to the power of n minus 1. That's our formula to find the nth term of a geometric series. Okay, so again, applying it, it's a straight substitution. If you need to find the nth term, then to find the 10th, we're going to say R. Well, let's have a look at we're going to say A. So let's have a look at our series. A, the first term is 1, and we're going to multiply that by the common ratio. Well, if it goes 1, 3, 9, the common ratio is 3. To the power of n minus 1, n is 10, so that means it's 3 to the power of 9. Straight into your calculator, you get a rather large number, 19,683. Something to note, geometric series, they get very large very quickly if that common ratio is more than 1. All right, let's have a look at this example. The 14th term in this series. Well, what's A? A is 2. And what's R? Now be careful, we're going from positive to negative to positive to negative. What that means is that our ratio must be negative. If you're not sure, just have a look. Negative 4 divided by 2 is negative 2. Okay? And again, be careful how you enter this. The 14th term is AR to the n minus 1. Right? So A is 2. Our R is negative 2. Use your brackets. N minus 1, so 14 minus 1, we get 13. When you substitute that in, when you type that into your calculator, you should end up with negative 16,384. Okay? Now try it for T15. I want you to have a go at that. I'm going to check your answer when you get back to class so that I can make sure you are all entering this correctly. Okay? Good luck. I'll see you in class.